Today's video is about modeling functions by transformation. I will use IA sample as the example. The topic for IA sample is modeling microwave popcorn. The exploration of modeling microwave popcorn is to determine the length of time to keep popcorn in the microwave by tailoring and interpreting a mathematical model. In this exploration, the author already used the exponential model, cubic model, sine model, and cumulative normal distribution model to model the data. I will use the same data given in this table. You can scratch the graph in decimals like this. This time, I will use transformation to model the function in this video. Before we get started, let's talk about transformation rules. For this A, we call this A is a vertical factor. If A greater than 1, then it will be vertically stretched by a factor of A. If A is between 0 to 1, then it will be vertically compressed by a factor of A. We call this B is a horizontal factor. If B greater than 1, then it will be horizontally compressed by a factor of 1 over B. If B is between 0 to 1, then it will be horizontally stretched by a factor of 1 over B. If A equals -1, then the function will be reflected across the x-axis. If B equals -1, then the function will be reflected across the y-axis. We call this K is a vertical translation. If K greater than 0, the function will go up k units. When K less than 0, the function will go down k units. We call this H is a horizontal translation. If H greater than 0, the function will move to the left. If H less than 0, the function will move to the right. There is a good way to remember the rule. It's a insider is a liar. Look at this B. When B greater than 1, it was supposed to be stretched, but it's a liar, so it's compressed. For B is between 0 to 1, it was supposed to be compressed, but it's stretched. The same thing happened to this H. We call B and H are insider because it's inside this parentheses. When H greater than 0, it was supposed to move to the right, but it's not. It moved to the left. When H less than 0, it was supposed to move to the left, but since this is a liar, therefore it moved to the right. Look at the graph of the data. First of all, you have to figure out the parent function. We know the pattern of this graph is very similar to logistic function. This is the general form for the logistic function. According to the information given, we know this L is equals to 83. Then let's check this B. B signifies the horizontal dilation. A horizontal dilation, remember that insider is a liar. So this dilation will stretch or compress the parent function horizontally by scale factor of 1 over B. And A, for this A, signifies the horizontal translation. A horizontal translation translates the parent function horizontally to the left or to the right. So let's make the logistic function f of x equals 83 over 1 plus e to the negative tth power as our parent function. First of all, I will copy that table into this decimals. Then you can go here. For the x-axis, you can change the domain. For the y-axis, you can change the range. I will label for x-axis is time seconds. And for y-axis is popcorn popped. So you could say this is a very nice graph shown in decimals. Then I will graph for this parent function. That will be 83 over 1 plus e to the negative x power. This is the parent function. Let's download this graph. Click here, export image, then download PNG. Copy paste to your Word document. In this way, we got the figure 1. Parent function f of x equals 83 over 1 plus e to the negative power and the data. To determine the horizontal dilation, I consider the initial maximum values. We know the initial maximum value is 83. For the parent function, the maximum value 83 at when t equals 9. Then for the curve, the maximum value 83 started at t equals 280. Therefore, 280 over 9 equals 31.1 is the horizontal scale factor. That means the horizontal factor 1 over b. Since the horizontal scale factor is 31.1, that's 1 over b. So we can figure out the b equals 0.032. We already figured out this b for this general form of a logistic function. Now we need to figure out this a. This is a horizontal translation. For this a, I will choose to use the middle line between minimum value 0 and a maximum value 83. That is 41.5. For the given data of a popcorn, I choose the point very close to this 41.5. That is 160.42. For the parent function, I need to figure out this t. When f of x equals 42, what's the t? T will be 0.024. So I will set up this parent function equals 42. Then you can figure out t equals 0.024. Therefore, the horizontal translation a, it will be 160 minus 0.024 equals 159.976. It's very close to 160. So I use 160 for this A, for this horizontal translation A. Since we already got this A and also the B, we can put into the general form of a logistic function. We get this. Then we can graph this function on the decimals now. Then you go to decimals and write down the function we got from transformation. This B equals negative 0.03 and A equals 160. You could say it's pretty much fit this data. So let me export this graph first. So for figure 2, it shows the function we got from transformation and the data. Then you can do some adjustment for this function. What you need to do is you will put in this 83 over 1 plus e negative b times x minus a. That's a general form. Then they will ask you add slider, then put the all. They give you the like a and a b here. Then you can change the number. It will be from 0. We know this is a 0.03, so let me do this one is a 0.05, like this. And for A, we know it's very close to 160. So for this A, I need to change from 150 to 170. Let me uncheck here. So you could say how close it is. Then you can move this one. Just do some more adjustment. I found 156 point something. Then over here, it will be 0.0293, kind of like a best fit. So you could say this one is your function modeled by transformation. Then you can download here, export. Then copy to the Word document. Then we got the figure 3. That's the adjusted logistic function. We use decimals to do a little bit adjustment to fit the data. You could say the graph like here. In this way, we already figure out a logistic model to model the data of popcorn.